All right, well, let's see. Good morning, everybody. I am Charlie Blackwell Thompson. I'm the Artemis Launch Director, and it is my pleasure to be able to spend some time with you this morning and talk a little bit about Artemis, the suite of missions. We're going to focus on Artemis II here this morning, but certainly we're going to talk about the suite of missions that returns humanity to the moon and then one day on to Mars. We have a fantastic panel here this morning. Again, we'll go over some of the specifics of how we're preparing for that mission as we prepare our crew of 4, again, for that journey around the moon. I'd like to take a moment to introduce this amazing panel and thank them for being here today. I have to my right Matt Ramsey. He is our Artemis II Mission Manager. I have Brad McCain, who is a VP with Amentum and the Deputy Program Manager at Kennedy Space Center for Ground Operations. I have John Shannon, who is a VP from the Boeing Company for Exploration Systems, and Kirk Shireman, down there on the end, from Lockheed Martin, who is also a VP with Human Space Exploration. So I just want to say welcome to this panel for taking part of your day, and then thank you to this panel members for supporting this discussion. So with that, are we ready to go this morning? All right, I love that enthusiasm. All right, well, we're going to start things off. Let's go ahead to the next chart. You know, this chart here to me is the embodiment of exploration. I remember seeing this during the Artemis I mission when this first became available. And, you know, the first thought I had was, what's this going to look like when you have a crew on board through their eyes? And then my next thought was, there's our beautiful home planet in the distance, and the Orion spacecraft in the foreground, and the moon in between. And for me, this is why we explore. This is why we go. This is of the moon. But one day, that entity, that body that is between our crews and our home planet will be Mars. And beyond that, who knows? The next generation of scientists and explorers will chart that journey. But to me, when I see this, that's what this picture says to me. It is the reason that we go. It is about exploration. And so I think it's appropriate to kind of talk about that for a minute as we think about Artemis II and our crews flying around the moon. Next chart. So Artemis is about a suite of missions. It's not a single mission. It is about establishing a capability for deep space exploration. So Artemis I completed back in 2022. It was an incredible 25-and-a-half-day mission, completed all of its flight test objectives, and that was in preparation for crew. And so the mission of Artemis II is about a year away. We will test out the crew. I know Kirk's going to talk about this. I don't want to steal his thunder, but we'll talk about the preparations for that. But it is about testing those crewed systems, adding that capability in, and then getting ready for landing on the moon on Artemis III. And then with Artemis IV, you begin to talk about an additional exploration capability known as Gateway. But all of this portfolio together prepares you not just for a return to the moon, but establishing a capability for exploration beyond, and one day going to Mars. Next chart. So with that, I'm going to hand it over to our panel members and have them talk. Matt's going to talk about the Artemis II mission and some of the objectives. So with that, Matt.
Hey, folks. It's good to be here. I see a lot of friendly faces out there that I've either worked with or have been friends with for 30-plus years. So let's go on to the next slide. We'll talk a little bit about priorities and principles. The number one thing, obviously, for Artemis II is crew, and crew, and crew, and crew. Those are our top 4 priorities. Anytime you're with the crew, They're rock stars. Everybody wants to go talk to them. They are fantastic people, and we're going to keep them. We're going to keep them safe. The next thing is vehicle survival. There are systems that we will reuse from Artemis that we've reused from Artemis 1 to Artemis 2, from 2 to 3. That list is getting smaller, but we will eventually start reusing full CMs. 3 will be flown on 6, etc. So vehicle survival and recovery is a huge thing. And then all the mission success activities that you see below, we've prioritized those, and really what those do are help us determine what's going to be rolled into flight day 1, flight day 2, flight day 9, that sort of thing. So again, you can see demonstrate there, but the ability to keep the crew alive is number 1. And that extends from KSC into the Orion spacecraft. There are crew systems that Brad will talk about here in a bit that we have added at KSC that weren't required for Artemis 1. So things like the emergency egress system and those sorts of things. And then, of course, on the Orion spacecraft, the environmental control and life support system that wasn't really, there were piece parts of it there for Artemis 1, but that was not the intent of Artemis 1. It was the intent of Artemis 1 was to shake out the rocket and shake out the Orion system from a performance standpoint. And then we get into some of the other things. I mentioned retrieval of the flight hardware, but we will also have the crew doing emergency and off-nominal capabilities. So for radiation, there's a radiation shelter on the Orion spacecraft. We'll get into kind of breaking that out and using it, although we don't expect any radiation events for Artemis 2. We will test those capabilities out. And then we have flight test objectives that will be done on the Orion spacecraft. We did a ton of them for Artemis 1 to help characterize what the Orion spacecraft performance was. We'll continue that with Artemis 2. And then we also have some science mission objectives that get rolled into some of the remaining objectives there. We also have secondary payloads on both SLS and Orion that I'll talk about here in a second. And there are obviously OCOM objectives also. So let's hit the next slide, and I'll briefly go over the mission with you. It is quite different than Artemis 1. If you recall, for Artemis 1, we did a TLI burn almost immediately upon separation from core stage. That is not what we're going to do for Artemis 2. You see the first racetrack there is a 24-hour orbit to shake down the environmental control and life support system. That will be done by the ICPS or the second stage. We'll also do a remote prox ops demo in that racetrack. That is it's about 2 or 3 hour activity where we're going to use the ICPS and the crew will approach the ICPS with the Orion spacecraft, do some handling qualities, back off, and then reapproach. So that's fine and course handling qualities that we'll be doing during that demo. Upon the termination of that demo, we'll have ICPS do a disposal burn that'll splash down off the coast of Hawaii. Again, we didn't do that for Artemis 1. It's quite a bit different. We do have some secondary payloads that we'll deploy off of SLS or the ICPS here. Those are international partner secondary payloads that have a number of different science objectives. So it's very exciting to be working with international partners there. And then as we come back around, we'll do the TLI using the Orion spacecraft propulsion system, 4 days outbound, 4 days return, and then splash down in the ocean. Similar recovery procedures that we had for Artemis 1. It will be off the coast of San Diego. We'll use the same type of recovery ship, LPD, but we'll be recovering the crew here. So. Let's go on to the next slide. So some of the other folks will be talking these deltas, but I get asked the question a lot is what's different between Artemis 1 and Artemis 2? And a lot of the hardware is the same. I don't think there's too much hardware that hasn't had some modification done to it. some very small mods, some are pretty big mods. The boosters are relatively the same. The core stage has had some minor updates. The engines are from the space shuttle program. We're reusing those engines. ICPS is very similar. It's got an emergency detection system for crew abort if necessary with the ICPS. And then Orion's changed quite a bit, and Kurt will talk that. The ground system has changed quite a bit. We've added 2 major things: the emergency egress system for the crew, in case there's an issue at the pad. The crew can get in the basket and do slide wire down to the terminus area. It's similar to the shuttle system, but different. And then, of course, we've added the big hydrogen sphere to be able to turn launches around quickly. So that's going to be used for Artemis II, but its real use is going to be Artemis 3 and 4 and beyond. So I think that was it for me. John, I'll hand it off to you.
Okay, thanks, Matt. So I'm John Shannon with Boeing. We build the core stage and procure from United Launch Alliance the modified upper stage. We can go to the next chart if you'd like. The goal for Artemis II is really centered around what Kirk's going to tell you all about with the Orion spacecraft, what Matt talked about for crew provisioning, keeping the crew squared away as they go fly. The flight vehicle itself really was proved out on Artemis I. It was a terrific mission, really no issues with the boosters, core stage, upper stage, everything performed as we expected it to. So there's really not a lot of change for Artemis II on the flight vehicle itself. What has changed is the way we process it. We took the opportunity, since there's a pretty significant gap between Artemis I and II, to build the structure inside the vertical assembly building at KSC that you see on the right-hand side, the big blue structure. And that is in High Bay 2. It gives us the opportunity to be able to stand up a core stage and do a significant amount of work on the core stage all at one time. When we're at the Michoud assembly facility where we build the core stage, it's laying horizontally. There's no place inside the Michoud facility for us to stand up that core and work on it. But we have that opportunity at the VAB. So in order to be able to process the vehicle more quickly, we took advantage of building this new capability at KSC. In the future, what you'll see is that engine sections, that's the white part at the bottom of the middle picture that holds the 4 RS-25 engines, that will be assembled at Kennedy Space Center. In fact, the Core Stage 3 engine section is being completed in the old space station processing facility at KSC. It'll be trucked over and put into that new blue stand-up facility. From MAF, we'll send the upper 4/5 of the rocket by barge, and we'll assemble that whole section together into one integrated core stage rocket and install the engines at Kennedy Space Center. So that's been a multi-year project for us to allow us to pick up the pace on how fast we can build the core stages. And also to save money. It's if you reduce the amount of time it takes to put the vehicle together, then you're saving hours on the rocket, and it saves us a significant amount of cost in doing so. So while the rocket itself is pretty much the same as we flew on Artemis I, the ICPS is the same. They're all delivered to Kennedy Space Center. Boosters are the same. The way we process it is undergoing a pretty significant change, and that's all to increase speed and reduce cost. But the important part of this flight is the human piece, and we're just trying to repeat exactly what we did on Artemis I. So I'll hand it over. Oh, yeah, good. You got it. Please skip the next.
Okay, it is on. Sorry about that. Good morning. I guess it's still morning. Go to the next chart. So I'm with Amentum. Amentum, we are the prime contractor for NASA's Exploration and Ground System program at Kennedy Space Center under what's known as the COMET contracts. NASA, new acronym for your NASA handbook, stands for Consolidated Operations, Maintenance, Engineering, and Test, which is why we have the acronym. And before we get started, next page, please. Yeah, a couple of things to highlight for you. Number one, I recognized this morning by my count, I think I've managed to scram 15 pictures in 5 pages. So if a picture's worth 1,000 words, I saved you 15,000 words that you don't have to hear me talk this morning. And so I'll try to do the rest of it in a couple hundred. And the other thing to highlight is that diagram on the left-hand side here, which we'll talk about in just a second, or I'll mention just a second. About hardware is all here. Hardware is at Kennedy Space Center, somewhere around the center. It's all built. It's all ready to finish processing, assemble, test. So Artemis II is ready to be integrated and launched. And that's our role. Our role is to receive all this hardware from our Lockheed Martin and Boeing friends and everyone else that supplies stuff to this. Finish processing if any is required. The pictures on the left, we build. Yep. So we build, assemble, integrate, test, check out, rotor launch pad, which is the center picture. Launch on the right, and then we recover at the end of this will be a 10-day mission, I believe. So it all seems very simple, right, Charlie? It's only 4 pictures, and that's a successful launch. And we'll point out, as we saw earlier, we did have a successful launch for Artemis I back in November 2022, which very proud of, was very excited to be part of, and very excited to be part of Artemis II as well. Next page, please. So preparing the ground systems, what are we doing here? Since most of 2024 and even toward the end of 2023, we started preparing for the Artemis II launch. And the picture on the left, the mobile launcher and the tower, you probably read about in the paper. There was some significant, we'll call it unplanned launch damage. We hit that tower with 8.8 million pounds of thrust. So the fact that there was some damage done is not surprising. We even had damage on shuttles after 135 missions on shuttle launch infrastructure. So that wasn't surprising, but there were some errors that we looked at that had damage that we didn't expect. So we went in, we ruggedized, we beefed that up, and there was some damage from the launch blast to things you might imagine, brackets, tubing, and deck plates, things like that we've spent the last year or so upgrading, fixing, ruggedizing. In addition to that, we took advantage of the time frame that we had on the bottom right-hand picture of the crawler transporter. We replaced Alco engines, generators, and the like for it to handle heavier loads in upcoming missions. So this will be a theme through the next couple of slides. Everything that we do takes a lot of planning, takes a lot of integration, takes a lot of thought, and it doesn't take much to throw those schedules off. So when you have a time spot to do major infrastructure upgrades like that, you take advantage of it and you do that. But what else have we done? The difference for Artemis II has already been told, is crew on board. And so the picture on the left there shows a flight crew. I don't think that was actual flight crew, but flight crew-like folks. How about that? So the emergent egress system, we have similar to Slidewire, that baskets that we had on shuttle. Larger capacity, different braking system. It isn't just a cut and ride. We actually do an active braking system on these things, so they're a little more complicated. Allows the egress the crew or the closeout crew if they're on the pad down the terminus area and into vehicles and into safety. The middle picture, which I'm initially a cryogenic engineer at heart, so I love talking about cryos and liquid hydrogen. That's a large sink in the world, 1.4 million gallons, 1.25 million capacity as far as capability to actually be used. Other bit of that is solid space. So. And why do we need that? Because getting to the moon is hard enough as it is, and if you limit your the ability to do consecutive tankings for whatever reason, you could limit your launch windows, and you could blow a window because of that. So this gives us, I think we use, John, I think 540,000 gallons of liquid hydrogen for the ICPS and the liquid hydrogen stage on the core stage. So our tank at the pad is 850,000 gallons, so this gives us another 1.2, so roughly 2.1 million gallons of liquid hydrogen to help Charlie get the launch off. On the top right-hand side, because of the crew, we have changed launch countdown processes and procedures. We've also changed the ground and flight application software code to not only incorporate the new systems that Matt had talked about, but to also enhance the ones that we have and take lessons learned from Artemis I, make the code better, make the systems perform better. Next page, please. So where we are today, processing Artemis II flight hardware, core stage was here last July. As John said, it's in the high bay 2 and getting work done there, and we're actually looking at pulling some of the work that would be done in normal processing in high bay 3 over to high bay 2 for get ahead and to improve schedule timeline. Boosters are being stacked right now. We should be done in the next 2 to 3 weeks, for complete with booster stacking. The LESA on the right-hand side is in the VB ready to install. So, and then the ICPS is, I think, middle of February. It's been around for a while in storage, waiting for us to get it, take it to the multi-purpose processing facility, MPPF, for tank or fuel loading. Next page. So look ahead, what's the road to Artemis II? Well, again, my job, especially, or Amentum's job, is to take all these components, assemble, integrate, test, and check out. We will, once the core stage is lifted out of high bay 2 and high bay 3 onto the boosters, we'll put the LESA, the Orion stage adapter, the ICPS, the service module Orion capsule, put the Orion panels on, the LAS on, launch abort system, and do the final integrated test and check out, which is what the middle picture shows. We'll roll it to the launch pad when we're ready, and we have a planned taking test that will be performed, and then we will launch Artemis II. Next page. So that's what we're looking for, right? Is another successful launch. Put our flight crew, Reed, Victor, Christina, and Jeremy, safely in orbit around the moon for the first time, I think, in 53 years. So that's the goal, and I may not show it. I'm always show some excitement. I am excited. I'm also practical, so. But yeah, it's a hard thing to do, and I'm happy to be part of it, and I know everybody up here is as well. So thank you very much.
Yeah, thanks, Brad. Next slide. So I'm excited too. It's a great pleasure to be up here talking to you today about Artemis, about Orion, and be up here with this esteemed panel. So I'm really looking forward to what questions you guys might have. So please save up your really hard questions and ask anyone from here on over those hard questions. I joined Lockheed Martin after a few years at NASA, and then I was given the opportunity in October of last year to take over the Orion program. So I'm really excited to be a part of Orion and really be a part of flying humans again to deep space. So I wanted to share with you a few pictures here, tell you what's going on, what we're doing, and then we'll see where we go from there. So the pictures here you see on the left is Artemis I. So that was the vehicle as it was ready to go. And flew, and actually it was a great mission. As with any missions, John said, well, it performed as expected. I'd say by and large, Orion performed as expected, but there's always learning opportunities, both from a flight and post-flight perspective, but also from a processing perspective. So we took that vehicle that's encapsulated there. It's actually here in Florida right now, and we continue to do testing. We did a bunch of testing up in Ohio here right before the end of the year. We shipped it down here. We're doing testing here in Florida now, testing and analysis to learn additional things from that flight. So not only did we learn it when we flew it, we're learning today, tomorrow, we're learning from that vehicle. The next picture you see there is the heat shield. That is actually the Artemis II heat shield that you see. And okay, so everybody's seen the heat shield. What's the big deal? I think to me, is when you look at it in comparison of that person, of the scale of what we're talking about, that's a massive, massive heat shield. To the right of that is the Artemis II vehicle. It actually doesn't look like that right now. We've put all the, if you look at the capsule on the top, we've actually put all the heat shields on the tiles, panels on that, and it's really coming along. We expect to be handing it over to Amentum here in April of this year, and it really looks great, making great progress on the vehicle. And the picture on the bottom is one of my favorites. I call it the family photo. So today, in addition to processing Artemis II and getting it ready to go, we actually are building Artemis II. And so 2 is there, 3 and 4 are here in Florida over at the ONC building. If you went out there today, you'd see both of those vehicles. and we actually have 5 and parts of 6 in manufacture at MAF in New Orleans. So we are processing and building multiple vehicles right now. And some of the things that we're focused on now is how do we accelerate the pace at which we can build and test this vehicle and get ready to go fly. Really is a big focus for us. So fly Artemis II as quick as we can, fly Artemis III as quick as we can, and accelerate our ability to build vehicles into the future. So that's what we're working on day and night, 7 days a week, 3 shifts a day. That's what we're doing. Really excited to go to actually go see these things do the job they were intended to. So let's go to the next chart here. Just to give you an idea, I talked to a lot of people about what Orion does, but you get an idea here that the heat shield, the velocities and the heat, the energy that has to be dissipated from a lunar return is significantly different. So 5,000 degrees is kind of like the outer edges of the sun. It's really, really hot. And of course you have to go beyond that for Mars. You see the distances there. So, okay, so what's the big deal? And it really goes back to what's the big deal about Artemis II. So it turns out that humans have been building spacecraft and flying them for decades. We actually have one that's exited the solar system. But it turns out to actually keep humans alive, it's pretty hard. Humans, while I feel myself to be pretty resilient, it turns out not so much. And so we have to be able to keep humans alive. You have to have everything you need to keep humans alive for as long as your mission is, all in that tiny spacecraft, and it all has to work 100% of the time. It's a big deal. But the thing that people, at least if you haven't worked in the human spaceflight world, you tend to forget is that things can go wrong, and you have to plan for things to go wrong. So today, when you fly, some of you may be flying here at the end of the week, go flying home. When you get on that airplane, if something bad happens on that airplane, if you're at altitude, you're probably 30 minutes from landing. If you happen to be flying to Australia, I'll give you maybe 3 hours from landing. If you're on the International Space Station today and something bad happens, okay, the earliest you could return is 90 minutes. Probably you're about 4 or 5 hours from returning, and you're safe. On Orion, if something happens, you can hit the emergency button, and it can be 9 to 11 days before you're to a safe harbor. So not only do you have to do the nominal mission, you have to be able to handle off-nominal situations for a really long time to keep that crew alive. And when I say crew, I don't just mean human beings. What I mean is personal friends. These people, and not only to me, they're probably to this panel members here, but to our workforces too. These are not just, hey, it's a crew member. It is a personal friend. Of course, you do it regardless, but it really is personal. This is very, very personal. So we take this extremely serious. So that's what's kind of online. When we build Orion, if you look at it, wow. In fact, if you go to KSC, you should go to KSC. You see this giant, first of all, you see the giant building. You can see it way before you get to KSC. You can see the giant rocket that Boeing and John is building. You can see that giant hydrogen tank that you just talked about in the launch pad, giant. And then you look at Orion, it's by far the smallest thing. But it's an extremely complicated vehicle, all crammed into a really, really small volume. So we're happy those big things exist, because it takes big things to throw Orion out at the velocities needed to go out to the moon and take humans farther than really we've ever flown before. Let's go to the next page. And we'll talk about this some more, I'm sure, in the future. But we are really, really excited about putting our friends on this vehicle, flying Artemis II, and not only learning about Orion, but learning new things for our species. So it's been a great pleasure to be here and talking with you today. Again, please store up your questions and fire at us. With that, I'll pass the baton. Let me say one more thing, too. It was December 14th, 1972, that Gene Cernan left the last footprint on the moon. 52 years ago. Actually, you could do the math, but it's 52 years in a month now that happened. And it's high time we went back and made some more footprints. So with that, let me pass it on back to you, Charlie.
All right. Well, I'm going to start things off with a couple of questions for our panel members while you contemplate yours. And then once we go through those, we'll have an opportunity for you to ask some questions. So I wrote a couple of notes. You guys probably saw me scribbling way up here while each of our panelists were talking. And so I'm going to go, I think, to Kirk first, because we kind of ended with you, and you were talking about how the crew, how it's personal, and how this hardware and this spacecraft are getting ready for crew. And so I was wondering if you could maybe elaborate a little bit on how the Lockheed Martin team is working with the crew to make sure that the crew and the vehicle are working well together as part of this mission. So how is the crew involved? If you could elaborate on that, and how is your team working with them?
Sure. Well, of course, I'll say the team's working great with the crew, but you probably have to ask the crew about that. We do actually spend a lot of time with them. Of course, all the things that the crew interfaces with during their mission is there in the spacecraft. So we spend a lot of time making sure that the layout, the seats, the configuration of the cabin is optimum for their mission. But there's also things like, hey, they're flying it. They want to understand where are the big risks and how are we mitigating those big risks. So we talk about the launch abort system. We talk about, we go over the heat shield details. We go over the carbon dioxide removal system. Even we go over the toilet. We go over everything with them to make sure they understand the risks, how those systems work, and show them that we're taking good care of them. So we do that. And then the last thing is actually handling characteristics of the vehicle. So ultimately, not on Artemis II, but future vehicles, we're going to dock with the lunar lander. So even on Artemis II, we're going to do some handling characteristics. They're going to fly the vehicle. They get to see, does it fly like they thought it would fly? Does it fly like the simulators that we have here on the Earth? So we spend a lot of time with the crew doing all those things for sure. And then above and beyond, the crew has taken it and helped us with not only our own workforce, but our supply chain workforce. We go out to suppliers, and the crew will come out and share with them their experiences, encourage us, and remind our entire workforce what's on the line here. So helping us in a lot of great ways, and I think the interaction has been very beneficial. I suspect they've been interacting with my colleagues and their workforces the same way.
All right, thank you. And let's see, I think I'm going to go to John Shannon next. John, I noticed when you were going through those slides that you kind of skipped past that SLS vehicle progression slide. So I wanted to ask you, since you didn't get an opportunity to talk about it, what is different as the vehicle progresses? What new technology is added in Block 1B and Block 2? I mean, what are the variants to come, and what new capability does that bring us?
Yeah, great question. If it's possible, if we could go back to the second chart under me, and I'll talk a little bit about it. The Block 1 that we're flying on the first three missions that we flew on Artemis 1, we'll fly on Artemis 2. You see, there you go. That's on the far left, obviously, and it uses a modified Delta upper stage built by United Launch Alliance. Very capable stage, gets the Orion spacecraft to through TLI on Artemis 1. It'll put Orion in a good orbit to go do all of its checkout on Artemis 2, Artemis 3, again, same kind of thing. But when if you look at Block 1B crew, so 3 vehicles over, that'll be the vehicle for Artemis 4. And that is when the SLS really becomes an extremely useful vehicle. The core stage is the same, the boosters are the same, the engines are the same. What's very different is the exploration upper stage. And as opposed to having a single RL-10 engine like you have on the ICPS upper stage, you have 4. It is the width of the core stage, so it's a much, much larger stage. But it's also a very capable spacecraft. You may remember, if you're a history fan of space, which probably most of you are, during Apollo, the command module would do a lot of maneuvering around to go pull out the LEM from the upper stage during the Apollo Saturn V missions. This one, a lot of that capability is in the exploration upper stage. The ability to fly specific attitudes, to be able to maneuver, to be able to be commanded by the crew. to be able to fly in, to allow Orion to extract anything really that you house in that universal stage adapter. Right now, the first 2 missions to use that universal stage adapter has elements for the Gateway space station. And then after all of that's done, the EUS is capable of disposing of itself and putting itself in a disposal orbit. So what really is useful about the EUS is not only does it give you a whole lot of additional power, a whole lot of additional lift capability to get hardware to the moon, it also gives you the ability to lift co-manifested payloads. So you're not just taking the crew module and service module of Orion, but you can also put things in what I call the big garage, that universal stage adapter, and carry them with you to the moon. Again, that's how we'll get a couple of the elements of the Gateway space station up there, and we can really carry anything else we want to. Now, other changes, it makes more sense since the exploration upper stage is really a spacecraft and has a lot of avionics in it that are required for it to fly. We said, it would make more sense to move some of those avionics from the core stage itself up into that exploration upper stage and have really the brains of the rocket be located in that EUS. That way you don't have to have 2, right? You save weight. You can fly the whole rocket from that exploration upper stage avionics, and the core stage is able to be a little bit lighter, and you don't have to carry as much. Again, that reduces the overall cost of the vehicle. So, first 3 flights really testing out boosters, core stage, the ability to fly the vehicle to a specific point in space. But if you really want the workhorse, you start getting that with the Block 1B and the exploration upper stage, where you can really carry a lot of hardware up to the vicinity of the moon. You talk about Block 2, it doesn't change really the EUS or the core stage. That's more with the boosters and their capability to fly more payload up. We show a cargo fairing there. That is an enormous cargo fairing. So if you wanted to take things like Mars transfer vehicles, other things up, that would be something that you could certainly do in a single launch with a Block 2 cargo configuration. That's it.
All right, thanks, John. Appreciate that. Let's see, Matt. I love that excitement. So he is ready for the question. So just, all right, so how will Artemis II help establish the common systems that we need for future Artemis missions and exploration beyond the moon?
Yeah, so crew transport for beyond the moon is the plans now is to be very similar to what we have to take the crew up to whatever vehicle that we would have to go to Mars or beyond. But the crew systems for Artemis II or the ECLS, the environmental control and life support, make sure you keep the astronauts nice and toasty and breathing good air. And the ground systems to support the crew folks also are very important and common from Artemis 2, 3, 4, and beyond. So that's crew safety, the emergency egress system, and how the crew goes from the ONC to the launch site and that sort of thing. So that's it.
All right, thank you. Well, let's see. I think, Brad, I haven't gotten to you yet. So why don't you talk a little bit about what happens after Artemis II?
Yeah, and the flippant answer is Artemis III, of course, right? But a lot of people don't realize, the preparation for Artemis III starts as soon as Artemis II clears the tower. And we go in and do some post-launch safing and securing it and immediately start doing washdowns to get rid of the SRB corrosive residue that's on our piping on the mobile launcher to prevent damage. We inspect for damage. Again, as I mentioned on ML or Artemis I, we had some unexpected damage. So hopefully all our fixes worked, and we'll verify that. And if there's something else that we need to go address, we'll look at those and document them then. So hopefully lessons learned were incorporated, and we are expecting minimal damage for Artemis II. I told you about the planning that's required to do these kinds of things, and the exploration upper stage that John talked about, well, that requires modifications in High Bay 4, and the time to do that is after Artemis II. So we'll be doing modifications on ground support equipment and up there during this next period when we have the slot. We have Mobile Launcher 2 that's coming online that needs an elevated tower for if you remember John's charts there, that the vehicles are taller. So there, among other things, that's going to be required. So we'll be doing test, verification, validation of that system and receiving it from the contractor. One thing that's important that we do, and I'm going to have to throw this out. I got so excited talking about the liquid hydrogen system, I forgot to talk about the ECLIS system. So I don't want to discount. Crew needs nitrogen, oxygen, water, waste management, all those kinds of things. So that is something we will check that, and as well as we had a new environmental control system permanent one that we installed in the VEB. We had portable purge units for Artemis 1. It will be a permanent one for Artemis 2, and then we also upgraded the pad system. So first thing we do is go look at all the systems and did they perform per plan? Did they behave the way we thought? Did they meet the vehicle requirements? If they didn't, then we'll go off and investigate that and maybe make modifications, or maybe the requirements too stringent, and we look at those kinds of things. So there's a whole lot of analysis that goes on even on the ground side in conjunction with the flight hardware guys to make sure that the system's performing as planned. And then we start looking at our RMSV flight hardware. Again, some of it will be there already, and when's the rest of it come up with integrated plans and schedules, because as we plan for the Artemis 3 processing and the upgrades that go with that, we also have to look at interplaying all the stuff for Artemis 4, 5, and 6, and where does that fit. So a lot of planning that goes on, and then there's going to be facility upgrades due to obsolescence and things like upgrade of cranes, for instance. So things like that we'll have to take into account and try to weave in there as well. So a lot of activity starting at launch plus about an hour.
Absolutely. Well, let's see. Anything from the panel that you didn't get a chance to comment on, or anything you want to add before we go to the audience for questions? All right. Well, let's see. I would just ask folks, I saw that we were lined up down here first. We'll just kind of alternate through the room until they give us the sign that we are out of time. So why don't we start with you?
Hi, thanks. Joey Roulette with Reuters. I had a question for each of the panelists, and I was wondering what you guys are telling your employees who might be concerned that the new Trump administration could come in and upend NASA's Artemis program and change things to focus more on Mars or new potential missions to Mars. And are you guys doing anything to prepare for certain outcomes?
I'll take that one first anyway. Be fun. So, yeah. Wait, what part did you say? Like the hard questions for these guys?
Let's do it in order. Yeah, we'll start. With
So first off, it's not my first rodeo, you can tell. And at least every 4 years, or likely every 4 years, an administration changes and there's uncertainty. And so, yeah, we tell them the same thing we tell people all the time is, yes, there's uncertainty. The best thing we can do is keep your head down and work as hard as you can and do the things that our nation tasked us to do. So that's what we're doing. Now, to just stand by and say, wow, let's hope everything works out, that doesn't make a sense. What we need to do is go tell the people in the new administration and anyone else we can talk to about is, hey, the fastest way to get humans back on the moon is to stay the course. And we all know that in this industry. You know, when you stop, things take a long time to build and certify, and if you throw them away every 4 years and start over, that's probably the slowest and most expensive thing we can do. So how do you stay the course? Let's put humans back on the moon, and let's do the things that we've been tasked to go do. And in fact, this administration was highly involved in those. For instance, President Trump actually signed the Artemis II hatch. His signature's on there right now. So I think we need to stay the course. We're telling people where we are today, and showing why that's the fastest course to go continue what we're doing. Don't throw it all away, and we'll be years down the road before we'll be having the same discussion 4 years from now. That's what we're telling our workforce.
Yeah, I think that's pretty consistent for all of us. Focus on the most important thing, and the most important thing is Artemis II.
Thanks.
Hi, Jeff Faust of Space News. Question for Matt. NASA announced almost 2 months ago a revised launch date of April 2026 for Artemis II. I wonder if you can say, how much margin do you have in that schedule right now, and what are some of the risks that you are tracking to that launch date at this point?
Yeah, so the April date's a no later than date, so that's how we're treating it, no later than. The agency has challenged us to do better, and we're in the process of trying to figure out what better looks like. So I'd say in the next few weeks we'll have a work to launch date that the whole team will get behind and start pedaling the bike fast to get to that point. So what was the second part of your question?
I was just saying, if any particular risk, any particular issues you'd be tracking that would keep you from meeting that April 26th date.
You're aware of the heat shield issue that's kind of behind us at this point. We've chosen to use as is on that with some operational constraints. Just putting the rocket and the spacecraft together is risky. I mean, we're gonna get through our testing, the normal plan testing. Insofar as other risks that are out there, we kind of work those every day. There's a whack-a-mole every day that we have to find problems, fix problems, and move on to the next day. So that's it.
Hi, Will Robinson Smith with Spaceflight Now. Maybe piggybacking on Jeff's question a little bit for scheduling, but to Brad. Kirk mentioned handing over Orion in the April timeframe. Assuming that doesn't waver, when do you expect to complete integration of Orion into the full stack? And by when do you need to wrap up the wet dress rehearsal in order to meet the no later than April 26th date? Thanks.
Yeah, I don't know that I can answer your question because I don't have the dates memorized in my head. Obviously, the sooner we get Orion, the sooner that we can do the entire integration assembly and check out and roll to the pad. As Matt said, a lot of the issues, we carry contingency in the schedule normally. In the case of this, trying to do the best that we can, you kind of take the contingency out and go, if everything goes right, what does it look like? And then, but things are going to go wrong. So what happens is when that happens, you have to regroup and try to figure out another way to a lot of things we can do in parallel. So we'll get things done in parallel where we can. So it's not a serial operation. So you kind of have to see when it gets there and then how it lines up with everything else that's going on. So I can't really give you a hard date, but obviously the sooner the better.
And is there a ballpark for when the wet dress is expected?
Charlie's the best one to answer that one.
So we are carrying in our baseline a tanking test. In terms of when we do that tanking test is a little bit variable. It could be as in the fall, I would say the fall time frame, depending on the configuration that we choose to pursue. If you do a full integrated tanking test, roll back, or if you do a tanking test more closer to launch. But I would say no earlier than that fall time frame.
Thank you.
Hi, I'm Taz Zaidi. My question to John is, when will we see the EOS hot fire test?
Okay, so the question is the green run out
Yeah,
at
the green run,
EOS.
yeah.
So delivery of the flight article of EUS will be late next year, and we'll configure at Stennis either late next year or early in 27 to do all that hot fire work. But so far it's going well. And what you'll see roll out first is the structural test article, which looks just like an EUS. We'll take it to Marshall Space Flight Center and do all the mean things that we did to all the other elements and put it through its paces. And then we'll go to Stennis and do the green run. And it's going to be a little different from core stage. This green run will do a couple of firings on it on purpose, right, this time. And we'll end up swapping out engines because those engines will not be vacuum rated engines. They'll be sea level rated engines. And then we'll swap out the engines and then send it off to the Cape for the first Artemis IV flight.
Got it.
Thanks.
And as for the heat shield, even though you're carrying the risk for Artemis II, you're going to keep the heat shield exactly the same for 3 and 4 and beyond. Like, what are you doing to circumvent that risk?
Sure. So what we're doing is we learned exactly what was causing the liberation of those pieces on the Artemis I. We did a tremendous amount of analysis and test and brought in experts, both our own Lockheed experts, but I'd say NASA experts around the world, to go fully understand what's going on. And we found there's a couple things you can do, but one of the things we're doing for Artemis II, of course, is changing the trajectory that we're going to come in, which is one of the operational constraints that was mentioned here. So we'll be safe for Artemis II, and for 3 and subs, we're changing the formulation of the heat shield slightly. So think of it as if you say, "Hey, I'm going to drink a soda," you can drink a Pepsi or you could drink a Coke. So it's kind of like a slightly different formulation.
Okay.
It still would be called Avcoat. So Avcoat is a product from Textron, but it's a slight variation of that, which we have tested and certified to show that it'll solve the problem that we saw on Artemis I.
All right. And my last question is for Mr. Ramsey. Good to see you again, sir. So what was your role in Artemis I, and how's it different in Artemis II?
Yeah, so for Artemis I, I worked SLS at the Engineering Support Center. So I ran the Engineering Support Center for SLS. This mission is, I'll be the mission manager for, so I'll be sitting in the bubble next to Charlie and working the mission management team. So.
And on that note, congratulations, sir.
Thanks.
Hi, Richard Trabue, Orlando Sentinel. Just to build off the Artemis III for Kirk, how soon you're about 2.5 years from the target for Artemis III, and Brad, this is going to be related to you for the turnaround. But for the coding for Artemis III, when do you have to have that in place and start putting it onto Orion? And then Brad, if we go up in April, that's 14 to 16 months before Artemis III. Is that enough time to turn around mobile launcher and all on the timeline? Is that going to be tight? Those are my questions. Thanks.
So from a heat shield standpoint, we actually manufacture this Avcoat in blocks in New Orleans at MAF, and we ship them out here to KSC and machine them, and then we lay them up on that giant heat shield that you saw the picture of out there right next to Kennedy Space Center. We've been building blocks since for Artemis III since October of last year, and so we've actually already started building it. So we're doing it as we speak. So there's the machining, and there's putting them up on the heat shield itself, and of course then inspections and so on. But that's happening here as we speak today.
Yeah, and as far as timeline, we would hope to do better than the 14 months, to be quite honest. You really can't use Artemis I's timeline as a baseline because of so many different things that we did, and again, the unexpected damage that we think we fixed for Artemis II that delayed getting everything started to be. And so, if the hardware performs like it should, and we get what I would call the expected response from the infrastructure, then 14 months is sufficient time to turn around. Hopefully, it would be sooner than that.
Well, just to follow up, what would be if everything was flowing, all the equipment was coming in on time and everything was good, what would be a launch to launch? We're talking through Artemis 10. What would a quickest turnaround be?
I think the target is 12 to 13 months for each.
Yeah, it's
or less.
12 months nominal, yeah.
Yeah, nominal.
Thank you.
So,
Hey, good afternoon. Gabriel Llamas, MGA Research. My question's for Matt for crew and, I guess, crew safety. Where can we find the standards or requirements for used for testing the occupant safety of the cabin?
There's a human, it's HSR, I can't remember what that stands for, but it's the human interface to hardware in spacecraft. So I can get with you offline. I can't think of it off the top of my head, but there is a standard for that.
Okay, thank you. Appreciate it.
All right. Well, we are out of time. I want to thank this panel. Thank you for Thank you for the incredible briefings and then for taking the questions. I want to thank this audience for participating, and I hope you have a wonderful rest of your day. Thank you.